Our next speaker is Christian Barra, who is a problem solver hungry to discover new things and dive deeper, whether related to his professional or personal life. Christian has a quite rich Twitter, so I encourage you to have a look after this lecture. Please give a big round of applause for Christian Barra with his speech, "Software is feeding the world."
Hi, thank you. Thank you for the great introduction. My name is Christian, and today I want to talk about why I think that software is feeding the world. So, first of all, do you know this guy? Have you ever seen this guy before? Raise your hand if yes. No, no one. Okay. So this guy is Mark Andreessen, is a venture capitalist, and he's one of the co-author of Mosaic. It's the first browser, and is also a co-founder. Was the co-founder of Netscape. And a couple of years ago, he wrote a really interesting article on the Wall Street Journal with the title "Why Software is Eating the World." This is a copy of the article. You can check it online. Actually, it's pretty interesting. I think it was written like in 2007. And the article tried to explain why software is reshaping our life and changing the world at the same time. But today, I would like to take that sentence and I would like to rephrase it a bit. So, can software feed the world? And before answering this question, I would like to ask you another one, which is, why should we bother? Does anyone know the world population today? Any number? 5 billion? 7. It's 7.7. And by 2050, it's going to be 9.8 billion. And it's a huge number, actually. And that number will put a lot of pressure on our ecosystem. And to feed world population by 2050, we need to increase crops production by between 25 and 70%, which it's a huge increase in production. But that's not the only big change that we will see in the next 30 years. What about people living in urban areas? So today, this 68%, it's about 53. So in the next 30 years, there will be a big increases in people living in urban areas, which means having cities with 20 millions, 30 millions. And that also means that the majority of the world population, more than 4 billion, will live in cities, will live in big cities. And if you think about this for a second, if the majority of the consumers are like in big cities, how do you move the food around? Can we keep producing food far, far away from the consumer? So we have a couple of problems coming from this growth of population. The first thing is that we need to avoid hunger. We also want to make cities more sustainable. We cannot increase like croplands. That's the size is limited. And sadly, because the majority of the Earth's surface is made by water, we cannot terraform the sea. And like these are not just problems, are also constraints. Like for example, increasing croplands, like I said, it's not possible because it's going to be counterproductive. Like we cannot keep destroying forest to make more land for us. And another thing is that we need to consider is that the world of like developing countries will change, will become closer to our habits. And that means that they will start consuming food in a much more different way, which is at the end closer to our daily way of consuming food. So what should we do? Like we have a big list of problems. These, to be honest, they are pretty big. They're like different solutions, like they keep talking about this thing for the last 30 years. like many solutions have been proposed, but at the end we can summarize them in three broad categories. So the first one is to change our diet, which means migrating from heavy red meat-based diet to a more sustainable one. That's the first step. It's something which was also suggested by the last IPCC panel. I mean, the document, the review from the International Panel for Climate Change. And these are the outcome of reducing croplands to feed animals. Another thing which is really important is reducing waste. I don't know if you know, but between 30 and 50% of the food which is produced every year, it gets wasted, like during the path, which is really a lot. Like if we produce like 3 tomatoes, just 2 or maybe 1 of them will reach our plates. And the last point is to use technology. And when I say technology, I mean like using technology to increase, for example, crops yield, so to get more from our lands, or to rethink about agriculture. And I want to show you a video, if it works. Yes. So I work as a senior software engineer and tech lead for a company based in Berlin, and the company is called Infarm. And what we do is vertical farming at scale. So what you see here, these black boxes, are not fridges, are not like just storage boxes, they are farms. And what we do is farming as a service. So we don't provide farms, we provide herbs or crops. And what you see here is a picture from Edeka. Edeka is the largest German retailer. And just to give you a number for Edeka in Germany, we produce about 120K plants each month, just for Germany and just for Edeka. What you see here is a farm. It's something that we developed like internally. It was I think like a 3 years old project. And we can grow currently inside each of these farms something like 35 different type of crops. Can be basil, it can be pak choi, it's pretty diverse. And we grow the food locally, like closer to the consumers, like inside the cities. And for us, a farm is a technological platform to grow food at scale, which means that we have this concept of farm. We can deploy the farm wherever we want. Can be USA, can be Japan, can be Warsaw. And we just need water, energy, and we can just grow things inside. And to give you more numbers and context, we operate right now something like 500 farms all across the globe. And the goal is to reach 1,500 in the next 4 months. And like marketing-wise, we use like 2 words which are like 100% local. It's next to your neighborhood. And because of the technique that we use, we can have like 0 pesticides. So when you buy something from there, you don't have to wash the plants because they are clean. So, but because this is like a tech conference, let's talk about code and hardware. So this is a mass production farm. It's the core of our production pipeline. It's bigger than the black one that you saw before, and it's what we have in what we call like hubs. So if you come to Berlin, we have an hub in Tempelhof. We are right now also active in Seattle in USA, and we have the same thing. So what we are using as a technique is called hydroponic. So we don't have soil inside the farm, but we have only water with the nutrients. And from the seeding phase to the harvest phase, it takes about 4 weeks. So in 4 weeks, we can pretty much grow whatever we want. And as you can probably imagine, like a farm is a really complex living system. I mean, we are growing living things inside. But from a technical perspective, it's a complex IoT device. And as a complex IoT device, we want to operate the farm. We also want to control the farm, but also we want to monitor the farm. And what what can we control inside the farm? Well, we have different sensors and actuators. We can control water, we can control air, lights, as you've seen from the video before. We also have pH control and the nutrients level. And because we are operating more than 500 farms, we need in different multiple locations, we need to do this at scale with different time zones, which is not really straightforward. And to accomplish all these things, we are using different pieces of technology. We use Python, mainly for the speed of iteration, because we want to deliver like features in weeks and not in months, and also because he has a really great ecosystem of libraries. But we also use C++ and also C, especially for the IoT part. We have some really strong hardware constraints. And like just to give you some number, we have like less than 100 kilobytes of RAM. So we really need to be wise with about the number of variables that we use when we want to put something new inside the IoT devices. And we are also using Go, especially for the new generation of farms. So as a software team inside Infarm, we have 4 areas of focus. We have what we call operations, farm control, monitoring and alerting, and crops quality. So operations are all the activities related to operating a farm. So we have this role of a grower, and as a grower, you go there, you clean the farm, you seed, like you put things, you put like seedlings inside the farms, you harvest things from the farms, and these are all activities that we provide and we schedule using a software. And then we have farm control, which is controlling the farms. Like I said, we can control different things inside a farm. We have different parameters, like water, lights, and a collection of all these parameters is what we call a recipe. So what we can do using the farm control is to send recipe, so a configuration, to the farm controller, the microcontroller inside the farm, which then apply all these parameters, like I want this water level for the next 4 hours and all these things. And then because we have such a complex collection of IoT devices, something that we need to do is also to monitor all of these devices and also alert people, because we have ops team in all the cities where we have like farms and hubs. So we collect a lot of data, which are like metrics, values, and statuses coming from the farms. Just to give you an example, if you don't have water inside a farm, that's a big problem because your plants are going to die. Is the pH too high? That's also a big problem because you're gonna burn the plants. So monitoring and alerting is fundamental because it helps operation doing a great job. And the last pillar is crops quality, which is about using data science and artificial intelligence to increase crops quality and also to fight and prevent diseases, or just to improve taste of our plants. So I took this screenshot like yesterday, and this is just one of our data pipelines. So we receive on a daily basis about 3 million events, and in a month they are about 90 million. And these are just events and data coming from the IoT part. But to be honest, to get here, it took like quite a long time, especially on a quality perspective. When we started, the company was completely different. Like at the beginning, like currently we are focusing mainly on B2B, so we work with big grocery chains. But before, like when the founders started, they were thinking more about B2C. Like, okay, I want everyone living in Berlin, I want them to be able to grow plants inside their apartments, inside their flats. But after a couple of months, they realized that that was like a good fit for the business, and they decided to switch. But they built the software for something completely different. So as the business changed, also the software has to follow the same path. So at the beginning, we had a really small team. We had a really big Flask application, which was like a big monolith. Everything, all the pillars were operated inside the same application. So operation, farm control, monitoring and alerting, they were all inside inside the farm, inside the Flask application. And we had, and we still have, a lot of background tasks and jobs. And a couple of months ago, we started like facing issues, especially when we grow like from just a couple of farms to hundreds, especially scalability issues. Another thing that we started to realize quite soon was that the software was hard to be maintained because we were relying on too many external dependencies. So there were like many libraries to do the things that we needed, but it was really hard to, as you grow your business, as you change your scope, it was really hard to keep like the same quality level. Another thing is leaky abstraction. So because we really didn't know what we wanted to do at the beginning, we were just abstracting things to be able to scale in the future. But we were really missing, the core part of our business. And for that, it took like quite a long time to say, now we are really sure about what we want from the application. Like all these side cases are not important anymore. And another thing which is quite specific to Python is what I call normalize. So all the business domain, all the business logic was partially inside the ORM, which is fine, but at the end, it's really hard to change your application and to evolve your application. And that's what I call like our technical debt at Infarm, especially for the software team. These are things we are working on and we are trying to improve every day. And another thing, and that's more on the upside, is that like when I joined the company, more or less like 1 year ago, we weren't using containers at all. So it was really hard to have reproducibility between like different devs. What worked on my computer probably wasn't working on your computer. We lack a lot of flexibility from one of our main cloud provider, which was Heroku. As we started to grow, we saw that many of the things that we wanted to do were really hard to do. And we had this incredible problem with metrics and logs. So it was extremely hard because they didn't matter before to really understand what was happening inside our applications. And last but not least, because we wanted to try, or because they wanted to try all the things available on the market, we decided to split our infrastructure across 4 different providers, which was pretty hard because then we started to see like how do we connect all these things together. We are running on AWS, we are running on GCP, we are running on DigitalOcean, we are running on Heroku. So our platform was scattered across different providers. And this is also connected to the normalized part and to the fact that we had this big monolith application. We were doing everything inside the application. So that means also ingesting all this data coming from the IoT devices. And that was killing our performances. So we decided to evolve, and we decided to evolve across these 4 different levels. So we decided to consolidate our infrastructure. We decided also to evolve our architecture. We decided to become more cloud native, and I will tell you more about this later. And we decided also to introduce a concept about observability. So the first thing is that we decided to deprecate all the cloud providers apart from GCP. So we decided to, okay, we're gonna move all our application workloads, servers, databases inside GCP. So everything that before was running inside, I don't know, AWS as a cloud, as a Lambda function will become a cloud function inside GCP. Another thing that we decided to, not just to say like, yeah, it's pretty nice to, yes, let's pay technical debt, but we decided to put time on this. So we decided to groom like our technical debt and to put like a serious effort into dealing with all these things. Why it's so important? Because we started to realize that many people were saying, I cannot build this feature, I cannot change this because I don't understand the software, or because it will take, I don't know, weeks or months just to, make this small change. And that was really slowing down the company and the business. Another important thing, especially for dynamic languages, is using linters. It really speeds up like the deployment, and you feel safer, and also you avoid having like tricky conversation about the style of your code and things like that, which are pretty boring. And we decided to reflect on these two concepts, like build versus buy and manage versus managed. Like especially if you're like in a small team in a fast-growing company like Infarm, we received like 100 million of funding during the last summer, and so we have a lot of money to spend. But at the same time, we need to deliver a lot, like in a really small amount of time. It's really hard, to keep on with everything when you have like a lot of requirements coming out from business. So we decided to avoid building new stuff if they are not really a core part of the business, and the same is about unmanaged and managed. So just to move on all the levels, on the architecture side, we decided to move on a more service-oriented architecture. We decided to start splitting our monolith into microservices or services. And this will not just help with having a more decoupled system, but also it will make clearer what are the separation between and the boundaries between your business unit. And another thing that really helped was to move data ingestion from a Python application to cloud functions. Now you have, scalability is not an issue anymore, and you can scale as your cloud provider will give you the opportunity to scale. Another thing, and is connected to the data ingestion, is that each farm has a Grafana dashboard. So every time that we change something on a farm, we had like a new sensor, or just because we are adding a new farm to a grocery shop or to an app in a city, that farm gets a dashboard, a Grafana dashboard with all the data. And the operation team can just go there and see all the data related to farm in a sort of super automated fashion way. So you don't have to do something as soon as we receive like new events coming from a new ID from an IoT device, we create a new dashboard. And there's not like the dashboard, but you also get the alerts and all these things. So another level where we decided to work on was cloud native. And the first action that we took was to containerize everything. Like now everything that we do is based on containers, on Docker containers. Every time that you open a pull request, we have a CI/CD pipeline, and what you get is a container and all the tests, all the QA related to that application, or to I don't know, just even about the deployment is a Docker container, is a Docker image. And to be honest, the next generation of farms, we will have containers running inside the IoT device. Another step that we decided to take was to introduce infrastructure as code. We are using Terraform at Infarm. It's pretty neat. It's basically you can destroy and recreate your infrastructure in a couple of seconds with just 2 commands. Like I said, each image is a Docker image, which is also pretty handful, especially if you have problems. You can just download your Docker image and you can test it locally. And we decided to migrate to GCP, and we decided to run all our containers inside Kubernetes. So we're using GKE, which is the managed solution by Google. And the only thing that we need to decide is the number of nodes that we want to run, and they will take care of managing the masters and all the boring things about Kubernetes. The other level, which is really important, is observability. Like when you're operating distributed systems at scale, it's pretty annoying to do debugging and try to understand your system, because you have these calls and they're like across multiple applications, multiple things, maybe also multiple cloud providers. So something that we are still like working on, and we are trying to put more effort, to be honest, is to, first of all, we decided to adopt structural logs. So now you have like contextual information when you log something. Who was the user? what was the origin of the request and all these things. Another thing is, it might look like naive, but we were missing metrics. Like we had metrics coming from the cloud provider, Heroku, but they didn't provide like a lot of information related to what we were doing and what we were not doing properly. So things like the number of 5x requests that your system is doing, or why is this error coming, or is this error like coming every day at the same time? It was almost impossible to answer these questions. And to integrate all these things, because we decided to migrate to GCP, we decided to put an effort on Stackdriver, which is the managed solution by GCP. And to be honest, I think that we put effort on logs and metrics a bit too late. Now we're really firefighting with all these things because we are like in a growing phase of our company where we are deploying more farms than releases in our software. So I really feel we started to, being like more concerned about the quality of our software, but also the quality of our infrastructure. And the implementation by GCP, it's really, really handy. Like, especially if you're using GKey, which is the Kubernetes by Google, you don't have to configure something. So you get logs and metrics for free. The integration is pretty neat, and then you can extend them if you really want. And if we take like a step forward and we think about the future, these are the things that we see. So we want to have a more service-oriented architecture, like I said, especially because we want to open our infrastructure to not just to new provider, but also to users, because we are collecting a lot of data, and something that we can really do with vertical farming, but in general with indoor farming, is running a lot of experiments. So in 4 weeks, we can see what works and what doesn't, and we can really find the best parameters to, grow your food. Also, just as a farmer, like what is the quantity of nutrients that you really need to provide them? Another thing that also we started to see, and we think that microservices will help, is to decouple teams. Sure, then you will have problems in defining like the proper boundaries and the proper interfaces between different teams and how their software will communicate with each other. But we moved from like just a couple of teams, like 4, to 10 teams, and now they have different requirements, different KPIs. So it's really hard to keep everything together, to keep everything on track. So, and they want to deliver in the same quarter probably. So something that we are experimenting, and we see it works more or less pretty well, although there is still work to be done, is to separate all the teams, define, okay, if you need to use my API, this is the interface, I'm not going to break it, and in case I need to do some changes, I will do like a pull request, and I will just ping you. And the last thing is you could like a focus on data, because it's extremely important. Like you can really play with the system, but you need to be aware of what is happening like inside. Like you can tweak all the parameters and you can get like amazing basil or amazing tomato. But you really need to control, what is the right amount of light that you need to provide to the plants? What is the right amount of water that you need to provide to the plants, and all these things. And like I said before, sorry, one of the things that we plan to do is to expand our platform. Think about like open data platform for farmers. So the future is not just that. Like currently we're working on the 2nd generation of farm, which is completely different from the picture that you see here. And there are like 2 main drivers. The one is fully automated farms, which means that we really want to reduce like labor work. And not just because it's expensive and you have a lot of people operating the farms, but also because people are a driver of diseases. So every time that you open a farm, you're putting something inside, and probably it's not good. So we have diseases coming from people, and it's really hard to fight them because we are not using pesticides. So everything that it seems like easy or like it's not a problem anymore in traditional agriculture, for us is like a big deal. And another thing is you maybe have Alexa and you can call Alexa and say, I want, I don't know, like 20 grams of basil the next week. And that's something that you can do with an automated farm because we can produce on demand. And another thing is that we can produce all over the year. So the concept of season for us doesn't make any sense because we can produce the same type of crops with the same quality, with the same nutrients in December or in July. It doesn't change much for us. And another thing, especially for the second generation of farm, is to change the microcontroller. So currently we're using a IoT provider, which is called Particle, which provides a really nice integration with the device and the API, but you're really limited about the things that you can do there. So you cannot run containers there. You have, I don't know, just a couple of kilobytes of memory, and that's everything you can do. So the next phase of Infarm is really about edge computing with artificial intelligence on the top. So the plan is to have like really computers running inside the farms, and there we will be able to run containers, run more software with like more complex algorithm and all these things. And these two things are really important because they will shape and change like the industry and the concept of vertical farms. Like, to be honest, like there are a couple of problems related to this system, which is we can use 90% less of water, but we use 10 times more energy compared to traditional agriculture. And we need to become much more efficient. And again, connected to edge computing, especially about the topic of artificial intelligence, what is really important is to be flexible. Like we have like some actuators and data, and currently when you want to grow something inside, we have this collection of parameter of configuration, which is called a recipe. And they're basically are coded. So you have a scientist, you have a biologist coming there every day and saying, okay, here I want to grow basil and something else. What is the best recipe? But maybe the best recipe in Wrocław is not the best recipe in Berlin. But right now, the only way to apply these changes is to go like on the website and apply them manually. What we want to do in the future, especially because we have farms all across the globe, is to put this freedom, this flexibility inside the farm. So what is the right quantity of light? It will be up to the farm to decide whether 10% or 90% is the right quantity. And to do this, you need to push a lot of competition closer to the farms. So, thank you. I hope you enjoyed the talk. And something that I really wanted to share is the power of technology when it's connected to the real world. Something that I didn't share, but that happens like quite often, like at least in the previous month, is that when you deploy like a bug in production, what you get, I mean, you kill the plants. But at the same time, you really see the effort and the outcomes of your job every day. Thank you.
If you have any questions, it's now a good time to come here and could you please come here? If we have more questions, please queue up in front of me.
Hi, I was curious about these evaluation of the quality of the crop. How does it work? If you could just highlight roughly how it evaluates automatically whether the basil is better or worse.
Sure. So there are like a couple of things. Some of them are quantitative, and some of them are qualitative. So we have like people tasting the plants, but also we have people on the qualitative side, on the quantitative side, taking pictures, because for example, for the grocery chains, they want to have a proper size and a proper weight. Another thing is that you can do like X-ray, and you can analyze like the nutrients inside the plants. So that's what we do right now. And you can do like other things related to to the color, for example, and to the quantity of chlorophyll inside. So they are like different parameters you can check.
I would like to ask you to stay seated for a while until the question part is over. Thank you.
Hi, great presentation.
Thank you.
I really like the idea. I have the question because we all want to reduce the carbon emission, and we know that energy usage is not constant. So you have the peak, and you have also energy which is wasted. For example, nuclear power plant is producing constant energy, but you don't need all this energy all the time. Do you think about using that, so give more light to what you are doing when the energy is cheaper, and do not use the light when it's not necessary, to give it more environment friendly?
So what I can tell you is that during the last weeks, we had a lot of awareness inside the company about energy consumption. That's like the main driver for the next months to reduce energy consumption. So you can play with different things. Like especially in Germany, we are just you can buy 100% green energy. But that's just one of the things that you can do. Another thing, especially when we work like inside apps, is to recover energy. Because yes, we can produce all over the year, but producing in Berlin or producing in the south of Germany is different, because during the winter you need to protect your plants and you need to keep like a certain temperature inside the building. And we're using energy to keep the right temperature inside. So something that we can do is to we take the energy and keep the energy inside the loop. To be honest, we can do. We are doing the same with water. So yes, we are consuming 90% less of water, but also we keep reusing the same water because we are filtering the water. So to answer your question, yes. Although we are not super flexible, because the light cycles, they depend also on the plants. So they have a period in which they need to get lights, but also a period in which they need to sleep. So we really need to mix all these things together.
Thank you.
Yeah.
Hi, I have a question related to what kind of crops can you grow in this system? Because you have a system which basically allows you to grow crops in an isolated environment. But I was thinking, do you have any limits of what you can grow? Can you grow, for example, rice or wheat, grain? Yeah, that's my question.
Okay, so the limit is mainly an economical limit, like what is worth like growing inside a farm, because then you have some like the cost is slightly different, and right now we are targeting like top market, like things that a chef like to have because they are fancier and because maybe you really care about taste. But sure, like if you want to deploy these things, I don't know, in third world countries and they need to grow rice, it's possible. So we are really experimenting a lot with new things, like we are trying to grow microgreens, strawberries, and all these things. So yes, to answer your question, it's possible. It's like making money, that's another thing. Okay. Yeah.
I have a question about how much of the environment are you currently controlling? Because from what we've seen, you can control amount of light, water level, and probably the composition of water. But do you also try to control temperature, air pressure, maybe air composition, or do you even monitor those parameters, because they all may have impact on how those plants are growing in different parts of the world, which you already mentioned that the recipe will be different depending on where you grow.
Yes, so just to recap, what we control is, so we control water, So we control the water level inside the farm. We control the air level, so the airflow. And controlling the airflow is a way also to control the humidity inside the farm. We don't control temperature, so we have a temperature sensor inside the farm, but we don't control the temperature. We have pH control and nutrients control. So that those are like the main things that we control. Like the next generation will have more sensors and will be more flexible on this side. But these are like the main things that we can move and the knobs inside the farm. So yes, like you said, it's more or less isolated, although it's not really at the end. Like if we think about like bacteria or like diseases, they're moving around, and it's really hard to isolate them because maybe they're using hair as a medium, and we are not really filtering hair. So that's really hard. Like I said, inside the apps we have temperature control, but it's like building-wise, it's not related to a farm. We are really experimenting with different things. One of the problems is that you need to do all these things like at scales. So what I mean is like, okay, you want to have temperature control, that's fine, but can we do this in sustainable way for 500 farms? And another thing is that we need to build and maintain a software for all the farms. So when you do a release for new hardware, then you need to retrofit things, but also you need to change software to be able to use the new hardware, but also be compatible with the old one. So doing changes inside the hardware, it's pretty tough. It takes like months compared to releasing software. So it will be more flexible definitely with the new generation. Like we learn a lot about how to create proper farms.
Okay, so I have a question. So what is the difference in retail price between this crop that you are creating and growing within your Infarm solution and with comparison to the traditionally grown crop?
So like I said, we target like high market, and the price, to be honest, is pretty much the same. Like if you go to Edeka in Berlin and you compare our plants, our crops with the competitors one, the price is more or less the same. I think we sell the plants for €1.30 each, I think, which is pretty much the same price if you buy like I don't know, like a basil plant, I think. So it's more or less the same. It's not super expensive. Like I will say it's pretty cheap for the quality that you get. It's like it's hyper local, and the main thing is the taste. The taste is completely different because when you get something from the south of, I don't know, Germany, Italy, whatever, then you have like 1 week in the middle between the harvest and when you get the things inside the grocery shop. And maybe they freeze thing in the middle to keep the quality, to keep the color, or they put some like chemical thing on top of that. So really, when you open a farm, you get all the taste, all the flavors. So yeah, quality-wise, it's a good price.
I have a question regards to the IoT devices you were talking about. You are mentioning about a container going to be running within IoT. What type of container it is?
Sorry?
You're mentioning about IoT devices that going to run containers.
Yes.
And what type of container it's going to run? That's what I'm asking.
Okay, so the next generation of farm we developed this new microcontroller inside, which is at the end is a big Raspberry Pi, but we will use Balena as a cloud provider, and inside, because it's like a computer at the end, you can run Docker and you can run containers inside. So you can test the software on your computer, and then you can just ship a Docker image, and you can deploy your image to IoT devices.